In this video, we complete step 37, Pivot Tables Part 1. So we're going to be beginning the pivot table method in this step. It is the most complex method in the entire project and will take multiple steps in order for it to be complete. So this video will focus on just getting started and discussing what exactly a pivot table is. So let's go ahead and look at this data I have over here. It's just an image of some City of Houston employee data. It contains 4 columns: department, race, gender, and salary. So this is the raw data over here. On the right hand side is the pivot table. So in this case, a typical pivot table involves 2 columns whose unique values will form independent groups. So in this case, we are using the race and the gender columns to form groups. So any unique combination of race and gender will form a group. So as you can see here on this vertical grouping column, this vertical axis, if you will, the race column has 5 unique values. The gender column is horizontal and has 2 unique values. So each one of these combinations of race and gender will be represented in the actual data over here. And this pivot table shows the average salary for those groups. So for instance, in the upper left-hand corner right here, this number represents the average salary for all the Asian females in the group. If we take a look at this cell, this contains the average salary for all Hispanic males in the group, or in the data. So that is a pivot table, a generic pivot table. So it consists of 4 pieces. One is you have one grouping column. You have another grouping column. Here it's gender. You have race and gender as a grouping column. We have a third column of values that will get aggregated. And the 4th piece is the type of aggregation. So we could have done some other aggregation besides the mean. We could have taken the max salary or the min, or we could have done like a count. But you have to choose an aggregation for a pivot table. So only one value can be reported for each unique combination of race and gender. So let's go ahead and look at the function signature over here, the method signature. We can see here that it does have 4 parameters. So rows is one of the columns whose unique values will form one of the groups. Columns is going to be another column whose unique values will form groups. Values is the column whose values are going to be aggregated. And values is almost always a numeric column, since numeric columns are the ones that are typically capable of being aggregated. The agfunc parameter is going to be a string of the type of aggregation. So this is going to be min, max, mean, median, standard deviation. All those aggregation functions are going to be possible here. So let's go ahead and take a look at what the final product looks like in a Jupyter notebook, just so you can get a better idea of how Pandas Cub is going to behave. So I've created a fake data frame with 8 rows. It has 3 columns. So I've actually created it with Pandas Cub and Pandas Cub Final, just so you can see how the final version looks. So this is a very simple data frame. And let's say, for instance, I wanted to create a pivot table such that I had the state as one of the grouping columns, and columns would be, let's say, fruit, the other grouping column. And I wanted to aggregate weight. And how did I want to aggregate it? Well, I'm going to aggregate it by summing it up in this case. We could choose a different aggregation, but that is a perfectly viable one. Okay, so what this is saying is that Texas has 15 apples, or pounds of apples, or whatever. Florida has 7 pounds of apples, 3 pounds of oranges, and Texas has 6 pounds of oranges. So you could go in here and verify that Texas and apples appears there, that's 5, and 10 here, that's 15. Florida appears here for apples 4 and 3, and that's 7, so it looks good. And then you can also verify for for oranges as well. So 2 and 4 is 6 for Texas, and 2 and 1 is 3 for Florida. So everything looks good there. But that is a pivot table. That is the pivot table that we're going to produce for Pandas Cup. Now, I'm just going to copy and paste this. We are also going to allow our pivot table to accept just either one of rows or columns. So we're going to allow our pivot table to work with just one of those. So in this case, we're just providing its state for the rows. So we're going to get the total weight for all of the fruit, regardless of what type of fruit it is. So all of the Florida fruit weighs 10 pounds. All of the Texas fruit weighs 21 pounds. Now we will allow either one to be observed, either rows or columns. If you do it columns, then you'll get a different view. You'll have just simply the unique values as the column names, and then the aggregation directly underneath them as a single row. And you can put any any value here. So here we put the fruit. We could change it to the rows and change the the direction of it, change its orientation. We could change aggregation methods over here. So there's a lot of possibilities that our pivot table will be able to handle once it's complete. So let's get started with the code. Now, I have actually just copied and pasted some of the code to get started here. And this is because I don't want to spend time on this beginning code. There's already some more interesting code that'll be written in the next step. But this is a step to get us started. So this code, what it will do, it does two things. Number one, it extracts the data into NumPy arrays. So it gets the NumPy arrays out of our data dictionary. And number two, it determines what type of pivot we're doing. Are we doing just rows? Are we doing just columns? Or are we doing rows and columns? So there's three possibilities that we're doing. So we've seen them over here. So this is one where there's rows and columns. This is one where there's just rows, and this one we can change so that it's just columns. So there's going to be three different branches within our program on what's going to happen. So either just it's going to either be both rows and columns, just rows, or just columns. Okay, so let's just walk through this code real quick to see what it shows. So number one. Both rows and columns cannot both be none. So if rows is none and columns is none, then we're going to raise a value error. We're going to say, well, you cannot do that. That is not that's not valid. You have to at least have one grouping column here. Now we are going to allow values to be none actually. So in that case, and I need to show you this how this works. If values is none, then you certainly can't have an aggregation on values that don't exist. So I had a small bug in the code and I fixed it, but it's still going to return an error here, or raise an error here. We're not going to allow someone to give us an aggregation function if there are no values to aggregate. So that simply doesn't make any sense. So back here in the code, we're in this branch where values is none. So values is none, and you try to give an ag func, which is now in this branch, then we're going to raise an error. Okay, so let's go back up to the case where values is not none. So if you give us a column for values, we're going to extract the underlying NumPy array. So we have to get those NumPy arrays into their own variables. Now if you give us a values, but you don't provide a ag func, then there's no way to know how to aggregate. So that will also raise an error. Now, there is going to be one case, a special case, where if the user gives us no values and no ag func, we're going to assume the user just wants to straight up count the co-occurrences of all the unique combinations in the data frame. So in this case, what we're going to do is make the agfunc equal to size, and we'll see there's a NumPy size function, which is why it's called size. It's not just called that for any reason whatsoever. We are going to create just an empty NumPy array as a placeholder for the data. Now we could sort of get around not doing this, but it is actually a fairly inexpensive operation, since it just puts nothing in there. It just sort of creates a data with whatever in memory with whatever data is actually already in those addresses. So this actually happens quite fast, so you don't have to worry about expensive computation here. Okay, so that takes care of the values and agfunc, whether they exist. Now in the next segment of the program, so we're just going to continue to collect our data into NumPy arrays. So if rows is not none, we're going to extract its data into row data. If columns is not none, we're going to extract its NumPy array into col data. So by the end of this line, we've extracted val data, row data, and col data. The last thing is to determine what type of pivot table are we doing. Are we doing something with only columns, only rows, or are we doing it with both rows and columns, which will be given the string all. So I'm actually over here, I should be, sorry. I was in the final, but it's the same code. So yes, it's going to be either columns, rows, or all. So if rows is none, that means columns is not none, it must be. Then our pivot type will be columns. If columns is none, then we know that rows has to not be none. So our pivot type is just rows. Otherwise, we are going to get both of them, and it's going to be all. So at this stage, there's no more code in this method. We can actually just go ahead and return, and I like to do this so I can slowly check my code. We can actually just return the pivot type. You know, this is just going to be one of these three strings. And I do this just so I could check on the fly, doing this sort of thing. So let's go ahead and let's make this valid. So if if I use rows and columns, it better return all. If it's just rows, it's going to say rows. If it's just columns, it's going to return just columns. So it looks like it's working right here at this point in time. Okay, so that covers setting up the problem and extracting the data from the NumPy arrays and determining what type of pivot table we are going to do. So we just did those two things, and that completes step number 37, part 1.